Hello. We're going to talk about multiplying and dividing rational expressions today. So we're going to be working from page 3 of your Chapter 2 notes packet. In order to multiply and divide rational expressions, the first job we have is to factor the numerators and the denominators, just like we did in the previous day. When we get done factoring, then we can divide out, or in other words, cancel the common factors to any of the numerators that you see and any of the denominators. So we can cancel common factors if they are directly in the same fraction on top of each other, or if one is in the numerator of one and one is in the denominator of the other, we can also cancel across fractions, and I'll show you what I mean by that. In the first example, we can factor this first numerator because there's a GCF. So you can take that out, that x out, and call it x plus 4. And I like to just lightly cross the polynomial out after it's been factored. X squared plus 6x plus 9 can be factored into x plus 3 times x plus 3. Over on the other side, there's a -1 in each one of these factors. So I'm going to factor out this -1 because both of these terms are negative. So if you take a -1 out of each of these, you're left with a positive x and a positive 3. So I'll cross that out, it's been factored. I'd cross that out, it's been factored. And then there's a GCF of 8 here, so I'll take the 8 out, and I'm left with x plus 4. So now I've completely factored all of the numerators and denominators, and now I can look for common factors to cancel. There's an x plus 4 on the top and an x plus 4 on the bottom. They don't have to be on top of each other, but they could. There's an x plus 3 on the top and an x plus 3 on the bottom. And then after I get done with those factors divided out, I can't do anything else. So now what I do is I multiply straight across. -1 times x is -x. 8 is on the bottom, and so is an x plus 3. And that's as far as I can go. I would never divide out those x's because they're not common factors. This x is a term because it's got a plus sign next to it. So that's the end of that problem. In question number 2, we can there are factors of -24 that add up to +5. They're 8 and 3. So +8 and -3. And this is the difference of two perfect squares, x plus 4 and x minus 4. And there are factors of -40 that add up to +6. It would be +10 and -4. So x plus 10, x minus 4, you multiply them and you'll get -40, add them together, you'll get a 6. And then the last one, the factors of -21 that add up to 4 are +7 and -3. So once you get done with all of that factoring, then you can look for the common factors. You've got an x minus 3 top and bottom. You've got an x minus 4 top and bottom. Don't ever factor two factors that are both in the numerator and the same. And it looks like we've gotten rid of everything that we could get rid of because there's no more x plus 8s or x plus 10s or x plus 4s or x plus 7s. So we're just going to put them all together in one fraction. X plus 8 in its parentheses, x plus 10 in its parentheses, and on the bottom we're left with an x plus 4 and an x plus 7, and that's all we can do to that. If you want to be real ambitious and FOIL these out, you're welcome to, but it's not necessary. We'll stop right there. Now this one is a little trickier. This one has some GCFs that are they're like the other day. In this numerator, there's an x squared in both of these terms, so I'm going to take them out. And I'm going to be left with an x here. If I take the x squared out of that, I'm left with a minus y. And in the bottom, there's a y squared left, or as a GCF, so I'm going to take that one out, and I'm going to be left with y minus x. Over here, I've got a y as a GCF, and I'm left with x plus 1. Don't forget the 1, placeholder here. And down in the bottom, again, I've got a y as a GCF, so this will be, x plus y. So when those GCFs are taken out, I'll just lightly cross those out so I can see what I've had in the beginning. And now we have some situations where we have an x minus y and a y minus x. If you remember that from yesterday, these are binomials. They're both subtraction, and they're in the opposite order, a negative y and a positive x and a negative x. We can cancel those down to a negative 1. Over here, we have a y on the top and a y on the bottom. And it looks like that's about all we can cancel out. So we have a negative 1 times x squared, and that's going to give us, and times an x plus 1. So we have a negative 1 times x squared is negative x squared, and then the x plus 1 stays. And in the bottom, we have a y squared that we haven't canceled out, and we have an x plus y. And that's all we can do to that one. Those x's will not cancel because they're terms. Terms have a plus sign beside them. In the next example, we have three different fractions that we're multiplying together. So we have a bunch of factoring to do. X squared minus 5 is x. If anybody wants to shut the video off and do this factoring themselves, I would encourage you to try this, and then you can turn it on and make sure that everything is like what I said. X minus 3 can't factor, but there's a GCF here. There's a 6. We can take it out, and we're left with x plus 2. Factors of 10 that add up to 7 are 5 and 2. So x plus 5 times x plus 2. Cross that one out. X plus 3 is not factorable, but 4x minus 20 has a GCF of 4, so we're left with 4 times x minus 5. So now we're going to look at all numerators and all denominators and cancel the common factors. We have an x minus 5 on the top, and way over here an x minus 5 on the bottom. We have an x plus 2 here on the top and an x plus 2 here on the bottom. They're on top of each other, but that's okay. We have an x plus 5 here on the top and an x plus 5 down here on the bottom. And then we're left with a 6 and a 4. And when you have a 6 on the top and a 4 on the bottom, they can reduce down by 2. So divide each one out by 2, and 6 divided by 2 is 3, and 4 divided by 2 is 2. And the x plus 3 and the x minus 3 are not common factors. They'll have to stay as they are. So now what we're going to do is multiply this 3 times this x plus 3, and you don't have to distribute it. You can just leave it as 3 parentheses x plus 3. That's fine. And then in the denominator, we're left with this 2 on the bottom, and we're left with x minus 3. And those x's can't cancel, those 3's can't cancel because they're terms. They're terms in a binomial, and terms cannot cancel. And that's the end of that. In this next section, we're going to be dividing. Now, dividing is the same thing as multiplying, except you're going to take the reciprocal of the second fraction. So this fraction, the right-hand fraction, we're going to flip this upside down, and then we're going to multiply. So we're going to go through the same process as we did before, factor everything, but then we're going to flip this upside down. And then we're going to go through the same process. So we have a GCF here of x. I'm going to take an x out, and it looks like I'm left with 2x plus y. In the bottom, it looks like there's an x squared as a GCF, so I'll take the x squared out, and I'm left with x plus y. In this denominator, this is the difference of two perfect squares, x squared minus y squared. Difference of two perfect squares will be x plus y times x minus y. Take that out. And then in the top, we have a y as a GCF, so I'm going to take that y out, and I'm left with x minus y. But now we have to flip this fraction. So this goes to the bottom, this part right here, and this part will go to the top. And I'm going to rewrite that so I'm not all confused about everything. So in the top here I had x times 2x plus y, and in the bottom here I was left with an x squared times x plus y. Now I'm going to put this in the numerator, this x plus y and x minus y. And in the denominator I'm going to have y times x minus y. So this has been flipped, and I'm just going to cross them off, and this has been rewritten. So what do I have now? I have an x plus y down here and an x plus y on the top. I have an x in the top and an x squared. Well, x over x squared reduces down to 1 over x. And it looks like an x minus y here and an x minus y here will cancel. And so now I'm left with just a 2x plus y in the top. And in the bottom, I'm left with an x and a y. Whoops. I guess I put parentheses around that. I didn't have to do that. Those parentheses can go or they can stay. But on the bottom I have an x and a y. And do not cancel those x's or those y's. Even though these are factors, these are terms because of the plus sign. In the second example, we have a GCF of 4y. So I'm going to take the 4y out and be left with y minus 1. Remember the 1 here. At the bottom, I have a 3y as a GCF. So 3y times y plus 2. 6y over 3y is 2. And now this is all factored, so I'm just going to move right now the y plus 2 to the top and the y minus 1 to the bottom. So that's been flipped. And now I can look for the y minus 1 common factor, the y plus 2 common factor, and these y's are factors so they can cancel. This y cancels with this y. So everything's been canceled out, and the only thing we're left with is a 4 on the top and a 3 on the bottom. So that's the end of that problem. On question number 3, it looks like we can factor this into x plus 2 times x minus 1. It looks like this is x plus 3 times x minus 1. This one down here looks like it's x minus 6 times x minus 1. And up here it looks like it's x minus 6 times x plus 2. But don't forget we have to flip this. So this top goes down to the bottom, and this bottom goes up to the top. And I'm going to rewrite it down here. But before I do that, let's see, I made a mistake here. This should be x plus 3 times x minus 1. Sorry about that. I hope you can fix that. So x minus 1s, I'm going to cancel those out before I rewrite this. So in this left-hand side, I've got an x plus 2 on the top and an x plus 3 on the bottom. I'm going to multiply that by this x minus 6 and x minus 1 go on the top because it's been flipped. And this x minus 6 and x plus 2 can go on the bottom. And I can see the x minus 6 will cancel out. The x plus 2's will cancel out. And it looks like I'm only left with an x minus 1 on the top and an x plus 3. Do not cancel those x's. Those are terms. Terms have either a minus or a plus sign beside them, and they do not cancel. Oops. And in the last example, we have 3 different fractions that we're going to be working with. Now this divided by means we're going to flip this fraction. Flip the second one only. But don't flip this one because this is a multiplication. Don't flip anything that's got multiplication beside it. So let's I'm going to bring these down here as I factor them. So x squared minus 36 turns into x plus 6 times x minus 6. On the bottom, looks like we have factor in, factor out. 2 times 18 is 36. The factors of 36 that multiply into, whoops, sorry. The factors of 36 that add up to negative 15. Let's see, there are lots of factors of 36. I think we'll have 12 times 3. So negative 12 times negative 3 will be that, the factors that add up to there. So we have 2x minus 12, 2x minus 3, but don't forget you have to divide out by 2. So this will become an x minus 6 over here once you get done reducing this down. So on the bottom, we'll have an x minus 6 and a 2x minus 3. Now remember, we're going to flip this one upside down and multiply. So this bottom goes to the top. This is the difference of two perfect squares, which is 2x plus 3 times 2x minus 3. And this top goes to the bottom. The factors of negative 12 that add up to 4 are positive 6 and negative 2, and they will add up to 4. So that's been flipped. But this last one, don't flip that last one. Just leave the 2 minus x on the top and the 2x plus 3 on the bottom. So now we can just look for common factors that we can cancel. I see a 2x plus 3 top and bottom. I see an x plus 6 top and bottom. I see a 2x minus 3 on the top and the bottom. Oh, there's an x minus 6 and an x minus 6 top and bottom. And the only thing we have left is a 2 minus x and an x minus 2. So those are binomials, their subtraction in the reverse order, positive x, positive 2, negative 2, so they can actually reduce down to negative 1. Everything is canceled in this except for the negative 1, so the final answer is just a negative 1. And that whole complicated set of fractions here, dividing and multiplying, just reduced down to negative 1. Isn't that amazing? I love this stuff. Anyways, have a great night, and I'll see you tomorrow. We get a lot more practice on this in class.